Good morning, everyone, or maybe good night for some people. Today, we will be talking about digital twins. And today's presentation is a special one because we have a guest speaker, Randy Murphy, who will be talking most of the presentation. And we will just, make the introduction and very quick demo.
So my name is Randy Murphy, and I'm the Geospatial Technical Lead with Aurora Engineers.
And I'm Dmitry Bach. I'm Scenario Creation Analyst at Safe Software.
Awesome. And we do also have Dave and Lena joining us on the back end for Q&A. So if you do have any questions throughout the webinar, leave those for us in that questions tab on the bottom right. The chat panel, you're all using it already. You can leave any comments during the webinar there. Yeah, share your reactions with us using that react emoji. We love to see them. And if you do have any audio issues, click that button on the bottom left, and there's 4 simple steps there to troubleshoot.
Yeah, so today we quickly will talk about, we'll show you a small digital twin demo, which I made just trying to understand the whole concept of digital twins. Then we'll talk about a little bit about Safe Software for those who are new and never used FME, our product. And then I will pass the presentation to Randy, and he will be talking about digital twins as someone with the expertise in this area. And then we will have Q&A at the end, so we will stay for a while and you can ask us any questions. Although, yeah, feel free to ask questions during the webinar. We have 2 people answering any of your questions. So, and here is our first poll. So, Elizabeth.
So you'll see this appear in the polls tab on the bottom right. And we'd love to know where on the path towards a digital twin is your organization. So you can place your vote there. And we'll give everyone a few moments. Votes are starting to trickle in there. Awesome. All right. It looks pretty evenly split between considering digital twin technology, familiar with what a digital twin is, and planning to implement. Okay, it looks like the biggest chunk is folks who are considering digital twin technology, though, so that's awesome.
Yeah, and that's very consistent with some survey results that we've recently seen where people have heard of digital twins largely, but are just getting familiarized with them and thinking about them, planning them, but only a few have begun to implement them so far. So it's a good topic and good timing, hopefully, for this webinar.
Awesome. And I think at this point, it's a good moment to turn off our webcams, our presenters, just to save on some bandwidth for the remainder of the webinar.
Okay, so Elizabeth, can we show the results somehow, or?
Yeah, so Dimitri, if you click into the tabs poll there, as people vote, they can see the results, or you as a presenter can also see clicking that eye icon there.
I see. Oh, wonderful.
Yeah.
Thank you. So just a couple of words about Safe Software. We started over almost 30 years ago, moving data between several CAD and GIS formats. And since that time, we grew into many different industries and data types. And overall, we have over 16,000 organizations using FME in like over 100 countries. We have a very extensive network of partners for many years. Some of them are friends for like 20 years or more. And we have a very, very active FME community where all the users from around the globe come and ask questions and answer them. So sometimes, or maybe usually, it's a lot faster way to get help is to ask a question in the community rather than talk to our support. Still, our support is really great, but there is a faster way because people are sitting around the globe it looks like they're just trying to help everyone with any FME related questions. So our platform consists of several products. FME Desktop is a graphic environment where we design how data should be transformed from where it is, where it needs to be. So we bring data in, transform in every possible way, and then save to a destination or multiple destinations. The most interesting part here is FME Server, where you can take those workflows and move them from desktop to the server environment or even a cloud environment, and then automate them or schedule them. So, for example, an email arrives or a Dropbox folder, sees a new file, something happens, and a workflow runs and delivers the results. So, and we have a couple of mobile apps. One is it's a client. FME Data Express is a client for FME Server, which not only can run some parameters that you would type, but it also can use phone or tablet sensors such as GPS or camera to submit those as inputs to FME Server. And we also have an FMER app which allows visualizing your data where it really belongs in the world. So this is the spread of our format support. You can see that we work with not just CAD in GIS, but with 3D, with rasters, with XML, with any databases, cloud, IoT, mapping, indoor mapping, augmented reality, and so on. So, and now a quick demo. So when I try to understand what a digital twin is, I thought maybe I could make some simple experiment. And I don't have a whole building to try it or anything else, but I decided to go to something simple and small, like crosswalk, for example. So I went to a local school and scanned with my iPhone all the crosswalks around it. You can see it on this map, those red rectangles, all the crosswalks around this school here. And you can see what you can get with the LiDAR scanner within the modern iPhone. So I can turn off the scans, and you can see the resolution of the imagery provided by the city. And then that's the quality of the scan. So it's like really probably a millimeter resolution. You can see it here. So pretty nice. So I made those scans, and I made 2 of them for each of the crosswalks with an interval about 5 weeks maybe, or 6 weeks during the winter. And it allowed me to see the change which is happening with the crosswalk. So this is the scan for December, and then a scan in January. You can see that the surface, the paint is deteriorates quite significantly. So I made some, added to my those scans some analytics. You can see how the quality of the paint deteriorates, the loss of white paint here. So what is interesting with digital twin, you can make a scan, for example, and it does not age, whereas the real world does age. So, and then you can just go and maybe see the difference. And that's why when we talk about digital twin, question of augmented reality often arises, because you can visualize your digital twin against the real world. I will run this short video here, where I went to one of those intersections, crosswalks, and overlaid the real world with the digital twin. So yeah, this is the real world. You can see not the crosswalk is not in its greatest condition, and that's a safety issue, certainly. And we also can see how quickly the paint goes off by comparing the augmented reality, so digital twin, with the current situation. It's easy to see what the current situation is because we have less, not more. And I think it's a really great way of comparing things, just where they are. Again, that's how it used to be. Versus how it is now. Yeah, and an important part of digital twin is not just having a copy of your a digital copy of your asset, but also maybe some feed, some dynamic data. And I remembered a few years ago, I made a very simple car counter with slit scan photography. And if you are interested, I can refer to, I can share the results, how you can do something like that, a very simple car counter where you take a video and extract just a single column of pixels from all the frames and mosaic them together and get a good representation where you have your car passing by.
Thank you, Dimitri. Okay. So to Dimitri's example of crosswalks, when he first mentioned it and we were planning this webinar, my mind immediately went to crosswalks between GIS and CAD or CAD and BIM data, because that's what I spend a lot of time doing, is trying to match these types of data sets up. But when I heard he was talking about real crosswalks in the real world, I thought about the example, and it eventually occurred to me that this is a great intro to the concept of a digital twin. We've got a feature, the crosswalk itself. It changes over time due to weather and traffic and other factors. And it's something that we can apply a sensor to, in this case, a remote sensor with the LiDAR scans, and detect changes in it that ultimately are a safety factor, because maintaining the visibility of that crosswalk is something important for safety. And so it's a perfect example of a digital twin at a small scale. So take that one example of a feature being a crosswalk and now expand that out to the campus of, in this case, Dallas-Fort Worth International Airport, which is an example we'll use today, and look at the complexity of this environment. It encompasses 17,207 acres. Interestingly, I learned that is larger than Manhattan in the city of New York City. So arguably this airport is, and most airports function very much like a city. So while the discussion today will focus on DFW Airport as an example, I think this could be applied to any large campus or large or medium-sized city in a similar fashion. More importantly, instead of just one or a handful of crosswalks, what we're looking at here is data that represents 950 to 100,000 different geographic features. And so you can imagine developing a digital twin to capture data and represent data about that comprehensive of a facility. So this video is showing what it looks like in digital or virtual world. And this is a digital twin for Dallas-Fort Worth International Airport. And we're focusing on one of the 6 runways that Dallas has. And we're looking at various data about this runway, the pavement and the condition of that pavement. But as we zoom in a little bit, we'll look at some of the features such as signs and what they look like to a pilot or to people that are maintaining those signs, markings that are on the airport, much like a crosswalk, but in this case used for safety of pilots and aircraft. And as we go forward, we look at different devices that are important for the safety of aircraft landing and taking off at this facility, such as this weather station that is sensing the temperature and different conditions that are important to pilots as they come in. And then we link that with a variety of sensors and bring in that information over time, real-time, past, and future predicted information, so that we can look at where there might be issues going forward and take actions on that. And so this is the beauty of the digital twin, is to take a facility as complex as Manhattan or DFW or what have you, and bring it down into the individual pieces that we need to operate and maintain and efficiently carry out this facility in a safe and effective manner. So now that we've seen what a digital twin can look like, let's talk about what is a digital twin. Well, one definition I've heard from a number of people in the industry is a holistic paradigm for transformation. And I kind of put that in a little bit in jest, but seriously, a lot of people have talked about it in very vague and abstract terms. And that may be helpful when initially considering what a digital twin could be to an organization. But when it gets down to actually building a digital twin and creating a digital twin, I think we need a more pragmatic definition. One I like is from the Digital Twin Consortium, which says that a digital twin is a virtual representation of real-world entities and processes. And I think that's really the important part of this definition. Synchronized with fidelity and frequency is also relevant, but the main thing is we're trying to represent the real world and the processes that we carry out in the real world. When I think about what those definitions mean, however, I think about, well, haven't we been doing this for years? We've been collecting geospatial data that represents our real world around us. We've been linking it to properties or attributes that we think are relevant. We've been connecting that geospatial information to other information systems and bringing that data in so that we can represent it in an intuitive manner. And then we've been looking at that data to try to make decisions. And so in some ways, we've been doing digital twins for many, many years. But there's still a lot of people out there that are saying, well, we don't know what it is and how do we approach it? And that's what we're trying to address in today's webinar. So one of the ways we try to shed some light onto the question of what is a digital twin is through the American Association of Airport Executives and the Transportation Research Board in the United States. We conducted a survey of geospatial practitioners which are looking at digital twins. And one of the questions of that survey asked, what are some of the components or things that you're looking for the digital twin to do for you? And although the chart on the right is a little hard to read, I've summarized it in these bullet points. And one of the main things that come out time and time again is it's the integration of systems and sensors. And those sensors could be remote sensors, such as what Dimitri showed with the crosswalks, or they could be sensors throughout a facility that are connected through the Internet of Things and are bringing live data into a single source. So integration is really the key to success of a digital twin. The data we're looking at is largely real time. People want to see the facility as it's currently operating, but also simulated and predicted in the future so that we can make decisions that will be effective going forward. We need to see this information in an intuitive manner. And the information we're looking at is geospatial in nature so that we can see an intuitive representation of the facility we're looking at. And interestingly, in the survey, that doesn't always mean that it has to be 3D. Although we've seen 3D, but in many cases, 2D representations can be just as valuable for certain use cases. It also can be schematics, particularly with complex systems, such as a baggage handling system at an airport or maybe a subway system in a city, where the schematic is just as good, if not better, because it simplifies the representation of the data. So the geospatial data can be represented in a variety of ways, but also the visualization of non-spatial data is important as well, meaning through dashboards, graphs, and charts, and other things such as the ones I just showed you in this a moment ago for the DFW example. So visualization is another key important. And then we want to take that data and do some analysis of it, because that's use the power of computers to help us understand what's going on with our facilities and our assets within our facilities. And we can leverage that analytics by layering on machine learning and artificial intelligence to take us into the future and look what things might happen. The ultimate goal is for humans, and we'll talk about who those humans are in just a moment, to make decisions, but also execute those decisions. And so while in many cases, a digital twin is read-only, meaning it's bringing data to decision makers so they can make decisions, in some cases, it also can be something where we provide inputs to it so that adjustments can be made live to our facilities through the digital twin. So it's a two-way flow of information in many cases. So who will use this thing called the digital twin? Well, part of our survey was to ask that question. And what came back is largely staff will use it. Consultants and service providers are in a secondary, close second, and then managers. So those are the types of people that will use it. But where within the organization will they use it? Engineering construction came in as the leading one. That makes sense because they're oftentimes the people that are building, constructing, and designing the facilities themselves. But there's such a thing as an owner's digital twin as well. So after the facilities are constructed, planning, operations, and maintenance needs those facilities to do their work. So we wanted to take a pause and do a quick poll to ask what types of things might you all be interested in using a digital twin for?
Awesome. And so you'll all see the poll appear there under the polls tab on the bottom right again. So yeah, let us know what use cases of a digital twin would most benefit your organization. And you can choose more than one answer here. Quite a few choices. So we'll give everyone a few more moments here to place their votes. Awesome. Okay, so it looks like maintenance facility or emergency response facility inspections, locating subsurface utilities seem to be at the top there. Is that what you would expect, Randy and Dimitri?
Yeah, absolutely. It's very similar to some of the survey results we've seen from other groups as well. So yeah, maintenance certainly a key element, and facilities inspections. Inspections often lead to maintenance items, but also one of the goals of digital twins is to do predictive maintenance, so they can avoid things going forward. I like the utilities one. Somebody once told me that they know what they can see, but that what they really need geospatial data for is what they can't see, such as things under the ground, and utilities are such an important part of our infrastructure.
Yeah, it's where really we have a relation to augmented reality. And during our conference in August, about 70% of requests for visualizing data in augmented reality was about subsurface utilities. So it's a good thing that we see here.
Yeah, good. So we asked the same question of that survey that I mentioned before, and this is just a word diagram of some of the answers that came out. But I think some of those same themes that we've seen in the poll are coming out as well. So maintenance is one of the key areas. Management of our facility is another one. Operations, inspections are part of the operations goal. Planning. Asset management, of course. One that came up as a surprise to me was lease management. So the management of our physical space and who's using it either as a tenant or as an occupant or a person going through the facility. The future of our facilities. A big payback. One of my colleagues said that he thinks that one of the bigger payoffs or returns on investment from investing in digital twins may come from the more efficient use of energy within our built space. And just the potential for cost savings there and adjusting a facility to the needs of the people within that facility as it goes. So these are some of the things that came out of our survey, and I think they're very similar to some of the poll results. So it's good to know. So why are these use cases important? Well, there's a lot of words on this page, but I'm going to try to summarize them down here. I like these quotes, and I've put the sources down below. So if anyone's interested in reading these full articles, but what we're looking at as a world here is spending $57 trillion on infrastructure through 2030, which is not that far away. And it's going to take these projects often 20% longer and 80% over budget. So trying to make these projects more efficient through the use of digital twin is important. But then in order to do that, we need to really transform how we're doing a lot of this work. And one of the things I've heard recently many times is that we're going to build things twice going forward. The first time is going to be virtual and the second time is going to be for real. And so to do so, we need to really leverage the power of geospatial and BIM to develop that initial digital twin of the facilities we're constructing. But more importantly, is transferring that digital twin over to become an owner's digital twin so that they can operate and to maintain the facilities that we build more efficiently. And the reason this is such important is the statistic shows is that typically 80% of the cost of a facility comes from during the operations and maintenance phase. And a scary thing that I learned through these quotes is that it takes almost a year to go through the information that comes out of construction in an as-built format into the systems that we need to operate and maintain our facilities. So a year goes by, and even more scary is that within the first 1 or 2 months of operating that facility is when the highest probability of failure occurs. So what we're happening is that people that are unfamiliar with their new facility are not having the information they need to properly operate and maintain it during arguably the most critical period in that facility's life cycle. So that's part of what we're looking to solve with the digital twin. And integration of data is going to be essential to do that. So the vision is a smart, and I put city in quotes because here we're looking at an airport example, but arguably it could be just a city. A city could be a campus. It's a complex group of buildings and infrastructure and facilities that represent what we're looking at. And what we ultimately want to do is increase our maintenance effectiveness, our operational efficiency, emergency response times, make our environment safer to be within. And in order to do this, we need an updated integrated data platform that's intuitive and can allow the variety of stakeholders that we have to make the decisions that they need. Yet some challenges exist. And one of the things that I've learned over the years is that oftentimes technology projects can be broken into 3 categories or 3 areas: data, systems, and organizational. And the challenges in data are, common getting access to the data, collecting data as a baseline. We'll talk about how we can do that in just a bit. more importantly, and through some of these survey results, people, after they've established that baseline, talk about data governance and maintenance as being the biggest challenge that they face, keeping that data so it's reliable and people can use it. But we also have technology issues. Vendor claims that they can do everything, including make your coffee in the morning with a digital twin. Procurement licensing challenges that are out there, especially with the complexity of offerings that we see with cloud offerings and on-premise offerings and et cetera, other types of things that are coming up. This goes without saying. We can have a whole webinar on this topic, but cybersecurity is really important. If we're talking about connecting so many different sensors and facilities and components and systems together, and then putting some of that information out in the cloud, making it available on mobile platforms, cybersecurity has to be an important topic that's discussed, and that is a big challenge to implement cybersecurity, yet keep the systems we're putting together functional. But what we found time and time again is that the real problems and the real challenges to implementing technology are not the data and are not the systems themselves, but it's the organizational challenges. It's the lack of direction, lack of understanding what we're doing here, understanding the use cases, demonstrating the return on investment to management that can provide the limited resources of time, staff, and money that we need to do this work. And then not just doing it initially at the initial stages of a project when there's excitement there, but continuing on with the hard work that's going to be required over the several months or years to really build this the system and sustain it. And then ultimately, as humans, we all resist change, it's part of human nature, and to assimilate the functionality of a digital twin into the organizational workflows of everyone in our organization is so important to success. So these challenges exist, but the key to solving all these challenges and the secret sauce, what we found, is data itself. And for a digital twin, that data is many things. It's the visual reference that we have of base maps and floor plans, but the points of interest that we put on top of those base maps, where are our assets that we need to maintain, where are the waypoints that we're trying to go to and from, where do things happen, and what are we observing in our inspections? And then where are we when we're carrying a mobile device in the facility so that we find these things? But we also need properties or attributes of these points of interest that are things that are static, such as maybe the make and model number of a given motor that might be in our facility, but real time, the condition or its operating status, predicted based on the maintenance history. Is this going to fail in the near-term future? And historic, what are the patterns that we're seeing? And then all this needs to be supported by good quality metadata that tells us what we're looking at in the data itself. So if data is the secret sauce or the key to solving the challenges, one of the biggest problems we're facing is that data is held in silos. And those silos are perpetuated by projects, meaning our built infrastructure is typically carried out by individual projects and tasks. And oftentimes, the information is not easily shared between those projects and tasks. But also within a project, different project phases. So when a project goes from planning to design to construction and ultimately operation, and each stage, as this chart in the bottom part of this slide represents, there's a loss of information. And that loss of information creates a problem for having that digital twin available when the facility opens during its most critical time that we talked about a second ago. Silos also exist between different departments within an organization, and then also between different vendors, having proprietary data formats, and also missions and strategies that are about their company's products and not necessarily conducive to tying products together between different organizations. And then also individuals are another source of silos. So how do we break down those silos? We'll talk about that as we go forward in terms of integrating the data. So speaking of integrating data, this is what a digital twin looks like behind the scenes. So many people have seen the very fancy and glamorous 3D models that we can orbit around and zoom in and pan and see a virtual representation of a facility, such as the example I showed earlier. But behind the scenes, what it looks like is a lot of different databases, a lot of different systems talking to one another through application programming interfaces, and then data being exchanged and transformed using ETL tools such as FME, and put into a platform that can really display this data in a consistent single pane of glass that shows us the information we need. So it's complex at the back end. So how do we get there? Well, I'm a firm believer that FME can really help in this process. So what we've outlined here is a path or a pathway toward achieving success with digital twins. The first part of it in the upper left is understanding that need. getting that direction that's so important to focus the limited resources we have on the goals of the use cases that we're all trying to achieve. So what are the use cases? What are the requirements of those use cases? And what's the return that we're going to get from them? But then assembling the data can be the next biggest challenge. And every organization, every facility has existing data. And so identifying that data, bringing it together, reviewing it, prioritizing it, and merging that data or conflating it together so that we can determine what do we have, identify the gaps as to between that and what we need, going out and collecting the information to fill those gaps, and ultimately bringing that data together, publishing it as an authoritative source, and then disseminating it through applications that can provide the analysis and decision support we need. So that's the upper portion of this chart. And the lower portion of this chart is maintaining that going forward. So the governance, meaning standards, procedures, policy, and metrics to monitor the quality of the data and the applications we're putting together. And then as we build new facilities, planning, designing, building them, and delivering the as-built data in a standardized manner that can be used to get the data into the digital twin as quickly and as efficiently and as automated as possible in order to have the functionality that we need day one when facilities operate. And then data quality. Data is never perfect, and so we need to constantly work toward that goal by tracking it, surveying, checking the data. So this is a path towards success in digital twins, but how can FME help? So I'm going to give some examples of how we're using FME at various stages during this process to support the creation of a digital twin. The first is to integrate source data. And so there's a variety of data out there in spatial data in CAD, increasingly in BIM formats, geospatial data, GIS data in geodatabases, shapefiles, you name it. There's a variety of sources of data out there. So what better tool than FME to bring that data together? So we've created some workspaces that interrogate data. The first thing we ever do when we get data from a client is we run them through this workspace. And it gives us a tabular in Excel spreadsheet of all the things we need to know: the structure of the data, the consistency of attributes, gaps in topology, issues in topology, all the types of things that we're very interested in when we look at data. We then want to try to match some of the things that we're most interested in this case, the assets from different systems, to identify how well they match up and the gaps that remain. Because oftentimes at an airport or in a city or in a large organization, the things that are most relevant are going to be represented in multiple systems in multiple ways. In many cases, they're represented in the same system in multiple instances. So weeding through that stuff is another thing that's really important. And not always is it going to be the case, in fact, seldom is it going to be the case, where unique identifiers exist amongst these long tables of assets that will allow us to pair them on a confident one-to-one basis. And so one of the things we've used is the fuzzy string comparison transformer, and to really look at how the assets are named and their identifiers to help us sort through them and make better comparisons with them. And given the volume of things we're looking at, you may recall almost 1 million features, geographic features at Dallas-Fort Worth Airport, this can't be a one-on-one manual basis. We need to leverage technology to do that, and FME really has been helpful to us in that process. Another thing is CAD, GIS, and BIM weren't constructed to be exactly the same. Yes, they all work with geospatial data and they accomplish similar things, but there are different purposes for using these tools. And sometimes the geometry needs to be different in order to support the different uses for the different software that we need. And so conflating data between CAD and GIS is another thing that we've had great success with FME, and making sure features match up with one another. And then we can, once we've identified a match, we can transfer attributes. We then want to convert that data into a desired format. In this case, we're using a geodatabase for that authoritative source. And so we're moving all the data into that final format, although many people are using other formats to store their authoritative source. We've chosen to use geodatabases for a variety of reasons that we can get into in the questions and answers if anyone's interested. And then another element here is associating room numbers and room polygons with the assets themselves. Many of the things in our built environment are referenced by the rooms in which they're in. And in order to effectively identify all those things that we're interested in, we need to effectively extract room numbers and room polygons from the legacy data that we have, which is often CAD data, increasingly BIM data. And we've used FME to do that, to extract those room numbers, oftentimes from annotations and not actual attributes, and then based on the room polygon, figure out what assets are within those rooms and assign those assets to that room number. So that's another very helpful thing. To create our ultimate storage, the geodatabase that we're using, we've gone out to the FME community, as Dimitri mentioned earlier, being a great resource. And we found some folks that have been using FME to develop geodatabase templates. So a geodatabase without any data in it. And so we've used that workspace and we've adapted it to our own purposes. And we're now generating the geodatabases that are needed for this Dallas-Fort Worth International Airport's digital twin using FME. We then want to extract the data from BIM and CAD to properly represent the assets. And this has been hard, particularly with BIM data, where the assets coming in, the geometry of them are very, very complex. You may have recalled earlier on when I did the video looking at a weather device, and that weather device was modeled so it had all the different antennas and sensors and all that were shown in it. Well, for many use cases, all that's needed is a point of that location. And so what we've used FME for is to take the complex geometry that we're seeing in many of these cases and culling that down to what we really need to represent and to satisfy the use case. We're also putting FME in place to validate the deliverables that come in going forward. So we've developed standards for both GIS, CAD, and BIM. And what we want to do is we want to validate that as data is submitted, it adheres to those standards. Because without standardized data, we're never going to be able to automate the process of ingesting the data or the relevant parts of that data into the digital twin. Once we have those relevant assets identified and the geometry properly represented, we want to register them in an asset registry. Because what we see is with all the different systems that come and go from a given organization, that given assets, as I mentioned earlier, can be represented many times or maybe not at all. And what we want is a registry, much like a motor vehicle registry or maybe a birth certificate that says, this is the identity of this asset and this is some pertinent information about it. It won't have all the pieces of information on about it, but enough to identify and be the sole source of the identification of an asset. So we'd register the asset in that asset registry. And then going forward to bring in this real-time data and really create a lot of the value of having sensors and information being tied together, we're going to be leveraging FME Server to implement automations to read data from the sensors, have triggers that will run certain workspaces based on things that are coming in, analyze the data and provide that data to the end users through an interface that helps them make the decision they need to go. So the FME automations is really going to be a great tool for the integrations element of creating the digital twin. We then want to get all this data out into apps. And those apps may be 3D in nature, such as what we're showing here, which is showing the complex 3D environment of an airport to satisfy a particular use case, and doing so through ArcGIS web scenes. And so that's one example, but there are many, many ways to publish data either in 3D format using either ArcGIS web scenes or many, many other 3D viewers that exist from Esri and other companies as well. And even some that are open source that can be used quite effectively here. And we can talk about more of that in the questions and answers if there's interest. And then to analyze that data and to visualize it in 3D so that very complex information can be understood very quickly and easily, and ultimately to get to the goal of making decisions. So going back to the question of how can FME help in the journey toward a digital twin, I would go back and ask, after thinking about it, what would you use besides FME? FME is the perfect tool to integrate geospatial data from a variety of formats and a variety of systems and then bring that together. And then with the power of automations in FME Server, it's a great tool to support the data, the real-time needs of that data going forward. And so I would love to have a discussion with somebody that would not want to use FME in the course of building a digital twin, because I think it is a great tool. And hopefully after this discussion, you all have seen some ways that it can be a great tool for you to use in your pursuit of a digital twin. So I wanted to share some of the components of FME that we found helpful when we look at the different readers, transformers, and writers that are available within FME today and also in the near future that can really support developing a digital twin. And I won't name these all individually, but it's reading the common formats that we've discussed already and then writing out to those same formats, but also some different formats like GeoJSON or the indoor mapping data format that is being used widely by a variety of applications to show complex interior space. And then some of the transformers that we use in any workspace, such as Attribute Exposure Creator, but also Schema Mapper has been very helpful at some of the matching that we've done. There was a question earlier about projections. All this data is also coming in a variety of different projections or coordinate systems, and so Reprojector has been another one that's been essential at bringing the data to a common platform. So ultimately, we see FME as a critical tool at achieving the maturity of a digital twin, starting out with standards, asset registry, and templates that we've talked about, building the data in an integrated manner, and ultimately tying things together. One resource that's available is the American Association of Airport Executives has a digital twin working group that anyone is interested in participating can join. And they've been developing a digital twin maturity model to help organizations understand where they are now and where they want to go with digital twins. So with that, we have our last poll of the day, which, given everything we've talked about, where do you think FME can help most in the pursuit of a digital twin?
Awesome. If you head back to the polls tab there, bottom right, you'll see that a poll has appeared now. And while we get people to vote here, it's probably a good time to turn back on our webcams as we prep for our Q&A portion after this. All right, looks like votes are starting to trickle in here. Looks like consolidation of existing data is the largest chunk so far, and spatial data quality control to follow. Pretty evenly split between the four, though. It's not, one isn't much lesser than the other. Yeah,
absolutely. And then systems integration as well. So, it's consistent with what I would have expected. Yeah, and bringing together data, that's such a key thing.
Awesome. All right, so just a few wrap-up notes before our Q&A, and I'll pass things over to Dimitri now. You might be muted here. I'll ask to unmute. Might be having some audio issues here. All right, well, while we wait for Dimitri here, I will, oh, there we go.
So, well, maybe I can just quickly run that video because, yeah, I have the video itself here. So
awesome.
That's, yeah. So now we see the world as it is, the real one, sometime in March. And I'm going to turn on the scan that I made in January.
And Dimitri, are you wanting to share your screen at this point?
I didn't, oh, sorry. Just one sec.
Yeah, no worries. Very cool.
So what can be your next steps? You can chat to us anytime. If you don't have FME, you can download it and try it and see how it works. You can download the workspaces. Will we have any workspaces for this? We might. I may share a couple of workspaces here.
Yeah, and also the videos we'll share out as well.
Yeah. So, and if you have any questions about everything you saw today, you can certainly talk to us. We have a few resources related to this webinar, a podcast. Our president, Don Murray, talked during this podcast about our vision of digital twin, a couple of blogs. One is published through SAFE website, and another was published somewhere else. It was, yeah, here.
EM360, yeah.
Yeah. So, and Elizabeth, could you talk about this?
Yeah, absolutely. So as a thank you for joining us today, we have a community badge code that you can redeem in the community. If you aren't yet a part of the community, we encourage you to check it out. It's a great place to ask questions, find solutions, and connect with other users. And if you have yet to check out safe.com/webinars, that's a great place to find upcoming and on-demand webinars. Lots of great resources at safe.com/webinars. And with that, we do have about 12 minutes remaining for some Q&A. It looks like we did address some questions in the question panel already, but I'll get our presenters to head back to that questions tab there and we'll take a look through.
Elizabeth, I saw a few questions regarding scanning and collecting LiDAR data and how to clip that data to be most effective, and then also georeferencing it. So we can maybe talk about that one a little bit. So yes, I think both in Dimitri's example, but also at most of the airport projects I've worked on, including DFW, there is an element, an important element of digital twins is reality capture. So going out into the field and collecting data, and there's a variety of technologies to do that, one of which is LiDAR, but others are georeferenced imagery. There's a variety of tools that can be used to collect data. So so with LiDAR in particular, since that was the question, clipping that is so important to be relevant. The LiDAR data can be so complex and voluminous that it really needs to be culled down to the information that's relevant. And so clipping that and working at it with small chunks at a time has been really important. So looking at the footprint of a given facility, looking at airports tend to be organized into concourses and piers within concourses. So typically we would break it down by that type of thing and create polygons and clip the data, process the data independently, and then ultimately use that LiDAR data as a means to identify features within the facilities. And there's some great machine learning capabilities that some of the tools, the software tools out there are now offering that can help us in identifying certain things in facilities, but they're not perfect yet. And so ultimately having imagery, LiDAR, and the base map or floor plan data merged together so that humans can quickly and efficiently go through and identify all the, let's say, trash cans and fire extinguishers, et cetera, that we might see within a building has been an important approach there. And so georeferencing that data to merge that all together is so important. And one of the ways that's been done is to establish control stations outside the building, but then bringing that control inside the building and establishing control, survey control within various components of the building, either through markers that can then be scanned and surveyed their location. And one colleague recently mentioned, particularly at facilities that are dynamic, such as an airport, is having that interior control be permanent, just like we have permanent markers, survey markers and control stations outside of the building that are maintained by the National Geodetic Survey. A facility owner should really look toward having interior control stations set up so that comparisons can be made over time as well. So that's some of the experience we've had with LiDAR and other reality capture technologies at airports. Dimitri, I don't know if you have anything to add to that with some of the work you've done in your crosswalk example and others.
Yeah, go ahead.
Oh, I was going to switch. If you have anything to add, go ahead. If not, there was some other questions I thought I'd try to address, Elizabeth.
Yeah, certainly. Go ahead.
Okay. One of the other questions that is near and dear to my heart is, as earlier I mentioned, I'm very focused on data, and this presentation has stressed the importance of data. So standardization is really important. And there's fortunately a lot of good standards that are out there to develop this type of stuff upon, and so that we don't have to create these standards from scratch. One of the key ones is the Building Smart International's Industry Foundation classes. And that's a great representation of BIM data in particular that can be used for ingesting into a digital twin. And one of the nice things about the IFC, Industry Foundation classes standards, is that it's extensible. So as an example, one of the groups I participate in at the moment is Building Smart International's Airport Room. And one of the subcommittees under that is working to extend the IFC model to represent some of the things that are unique to the facilities I work mostly with, which are airports, that don't exist in the rest of the world. Things like baggage handling systems, navigational aids for aircraft, these types of things are unique and need to be modeled as well. And so the IFC is a great place to start. But within buildings, and also much of our built world is consistent. And so another one that we've used extensively is Uniformat, specifically Uniformat 2010, as a means of categorizing the different assets that exist typically within our built environment. So that's another key standard that's out there. And there are a variety of others, but those are some of the ones that leap out.
Awesome. All right, any other questions here? Looks like we have one or two remaining, so I'll just put out a last call. If you do have any questions, drop those in the question panel there, and we'll try to get to as many as we can.
Yeah, some of the questions in chat talk about the variety of data sets that are available, and one of the people posted in the chat a complex situation that they're facing, and so I think the data integration, harmonization of data is so important. So that's certainly stressed a lot. Let's see. And they also talked about the looking at 3D, but not only 3D, but 4D and 5D, and looking at the life cycle of data and facilities over the course of a project. I think that's important for the concept of a digital twin as well.
Yeah, thanks for sharing that insight there.
So, Randy, what do you think about this question from Tim Alti? Collaboration is vital for cutting-edge work like digital twins, but clients and providers are often cautious to share their data work. Do you have suggestions on convincing clients on the value of sharing with the community?
Yeah, well, that goes back to the organizational factors I mentioned earlier, which continue to be the most challenging, is that people don't want to share their data for a variety of reasons. One is the data is, as I mentioned earlier, in my experience, data is never perfect. And people don't want to put something out there that they've created or are tasked with maintaining that's not perfect. And so if you put those two things together, then people will never share data. And so trying to convince people that we're not expecting data to be perfect, and it's not an embarrassment to have data that's not perfect. In fact, it's quite normal, and that we can be better off collectively if we can share data and help each other improve our data sets. And so that's one challenging thing. Another thing is just people feeling that their data gives them a competitive advantage or a reason for existing within the organization, fearing if they give up their resources, they may lose some credibility or some capability within their organization. And again, I think it's maybe the reality might be just the opposite, in the sense that if you're shown as somebody that is a resource for information people need, as opposed to somebody that's hoarding it to yourselves, it's maybe you're seen as a more valuable component of that organization. So these are some of the things we see. And breaking down those barriers is ultimately the task of stakeholder engagement. And stakeholder engagement is just constantly reaching out to people, meeting with them, finding out what their issues are and working with them. And it's sort of some of the more abstract elements. I mean, as technologists, we're all focused on developing code and matching data and checking data to make sure it adheres to a standard. But sometimes the harder part is working with that human element. And so I think that can be a challenge. So it's good. Yeah, good that you mentioned that, Dimitri. Thank you.
Excellent. And it does look like we have time for one or two more questions, and we've got one more here. And this individual is asking, how did you integrate the sensor data? And I believe that's a question for you as well, Randy.
Yeah, good question. And so sensors are so important to looking at that real-time environment that we're looking at. And so one of the capabilities that FME has is looking at, is reading, for instance, Azure IoT services or Amazon Web Services, real-time data feeds, and other types of things. And so we're looking to those formats to be able to read data in from the variety of sensors and connect it through FME server using the automation so that that data can be connected to FME, and then the data can come in and processed. But those are some of the standards or methods we're looking to use to do that.
Excellent. And I think with that, it looks like we've gotten to all questions in the Q&A panel at this point. Our presenters will remain on the back end for the next 2 minutes here. And if you do have any other questions come up, feel free to drop them in the panel and we'll stay on the back end. If you have any questions come up after the webinar, definitely get in touch with us. We're happy to talk anything data, info@safe.com, or connect with us on the community. And if you do have a brief moment to fill out our webinar survey, we appreciate any feedback you can provide us. I did just drop that link in the chat there, so you can access that there. Huge thank you to Randy for joining us as a co-presenter here this morning. We really appreciated all your insight and time on this, and to Dimitri as well, and Lena and Dave on the back end for Q&A.
Thank you for all who have attended.
Thanks everyone for joining. Have a great rest of your day. Bye for now.